Okay, we'll wait one more minute. Real quick, everyone has masks, correct? Okay. If for some reason you ever, like, you're almost to class and you're like, oh man, I forgot my mask, I usually bring a few extras to class, okay? Just because I think otherwise they have someone in, like, the student union or something like that, but by the time you get there and back, class will be half over. That's right, they didn't. Okay, so let's get started. We're kind of limited on time versus our normal semesters. Um, so let's do a quick survey of where we are in the course. So first of all, everyone who's needed to get to the lectures has been able to, correct? Everyone, how many people rewatched one of the lectures? Show of hands. Or missed class? Anybody? Okay. Well, just so you know, they are there and available. I'm just going to, even if nobody's really watching them, I'm still going to record it just because we may end up with a week where something happens and, you know, you can't show up to class, and so it's not a huge amount of work on my part, and it may help some people out at a later point, okay? So as far as assignments go, it may seem like you have a lot out there, but it's not as bad as it seems. So this is the assignment that we started. We'll go over that. We'll do a very quick computer build. I want to move on to the next section of the course. This is an assignment that I think it's just an important skill to have. It's not worth a huge amount, but I'm always amazed at, I shouldn't say amazed, but there are some people who've never really installed a program. Like, you might have gone to the App Store, and because so many things are, I shouldn't even say I'm amazed because that's kind of the direction everything's going, but these days it's becoming more and more common to use apps that are either web apps that you don't have to install or apps that you install from some sort of app store. But the actual process of going through and installing software on a PC, even though it's not terribly difficult, I'm noticing it's becoming less and less common for people to have that experience going into this class. So what I usually do is just say download a piece of software, and I make the recommendation Firefox, but really it can be anything, and I can give some suggestions, and then all you have to do is take screenshots of that installation. And we'll go over that in a minute. The other skill that I want you to learn in that process is being able to take screenshots, because that's another thing that I've noticed. You might have taken screenshots on your phone. I just want you to know how to do that on a PC. What I'm noticing is that I haven't even been here that long, just a few years at IRSC, but in that time, we've gone from phones being like a secondary device, where most people do most of their work on their computer, to now more and more people are relying on their phones as their main device, and they're kind of using their PC in a secondary fashion. However, for almost all jobs, your PC or your computer is still going to be the main thing. Like if you're working as a secretary or something like that, you're not going to spend all day on your phone. You're probably going to spend all day in email programs and like Microsoft Word and stuff like that. And that's kind of tough to do on the phone. But for most people, your day-to-day activities, like your banking and your just staying in contact with people through maybe social media and email. That tends to be done through the phone, but most office work still does tend to be through a regular PC. So this is going to be a recurring theme throughout the course, is that these might be skills that you already have on your phone, but I want to make sure you know how to do these things on your PC. And then assignment number 3, so this one's going to be due in 1 week. Don't forget that you can always just click the assignment and it tells you the due date. So this is due in 1 week. Assignment number 3 is due in 2 weeks. And so assignment number 3 going forward, this is going to be more the pace of the course, is that you're going to have something to do every couple of weeks. The reason I do a few that are bunched up toward the beginning of the course is because the general opinion of IRSC is that you should have some early feedback on how you're doing in the course. And the easiest way for me to do that without giving you an overwhelming assignment is to do these smaller assignments, like building a PC and taking screenshots and stuff like that. Okay, so let's go ahead. Any questions on anything before we start the actual course material? Let's very, very quickly go through a PC build. So before we went to Newegg, but we're going to save some time here. Did anybody explore this site more, like maybe exploring some of these builds or anything like that? Okay, you did a little bit. Which type of build? Gaming builds or? Yeah. Yeah, and they have some interesting stuff. Like, for example, and some of these are pretty well thought out. That if you are a little bit low on cash right now and you want to build a new gaming computer, $500 for a gaming computer. It might not, run everything at all highest settings, but it'll be good enough to play some games. So that's why some of these are worth exploring a little bit. But what we're going to do is we're going to start a system from scratch. If you already have a system that's started, I think there's like a way to restart or clear or something like that. When we do these sorts of things in class, I do ask that everyone follows along and does it on your computer too, because there's no point in just watching it, because then what are you actually learning? So it's more like a math class. If they were doing some math problems on the board, you would also do those problems. Even if nothing else, if you're just copying it, but you kind of gain some skills along the way. Okay, so let's choose a CPU. And we'll build a medium high end, I guess. So we'll do this chip right here, the Ryzen 7 3700X. And remember, the CPU kind of sets the stage for everything else. So this one I'm pretty sure has a built-in cooler, and you'll learn more of these details in the A+ course. But the cooler does exactly what you think it does, is that CPUs run extremely hot, and they just need something to cool them. Some will come with a built-in stock cooler, which will generally be good enough. And if you plan on doing anything out of the ordinary, that's when you start to buy aftermarket third-party coolers. But, to save time, we're just going to do that. And then the next thing is the motherboard. Now, this will automatically tell us compatible motherboards, but one of the things that we have to remember is that the main compatibility point between a CPU and a motherboard is going to be that socket type. So it's sort of telling us that the socket type is compatible already, but in your write-up you have to state these things specifically. So let's just add the first one here. MSI is a decent brand. And then your memory. Remember that motherboards support a certain range of memory. There was a point when DDR3 was still popular. Now it's pretty much all DDR4, so you don't really have to worry about the differences between 3 and 4. It's almost all 4 now. I haven't seen 3 in a very long time. But you just have to worry about speeds. So you want something that's within the range of your motherboard. If you get something that's really slow, you're just kind of wasting your money. Like if you've got this motherboard that you spent all kinds of extra money that supports really high RAM speeds, and you buy very slow RAM, it's kind of a waste of money. You might want to either adjust your motherboard or increase the RAM speed. But we'll take this first one right here. Now, it's very often that you buy these in pairs. That's what DDR actually stands for, is either dual or double data rate, and it can read from both modules at the same time. They actually even have quad. I haven't seen that in a while. I think that kind of went down in popularity, but and you can see right here, yeah. So it's a 16 gigabyte kit, but it's 2 modules times 8 gigs. Okay, so the main compatibility thing is going to be memory speed. Now we get the storage, and the 2 things that we have to worry about with storage is either that it's a mechanical hard drive where there's a platter that spins and it reads a bunch of magnetic bits, like almost like a record player. Or if we're doing a solid state drive, they have these form factors with M.2. So you just have to make sure that this motherboard supports M.2 2280. There was and I think I've mentioned this before. So most mechanical, what we call hard disk drives, you'll see the acronym sometimes HDDs for hard disk drive. Most of those brands are pretty decent. Seagate, Western Digital. I'm sure there's bad individual models from each company, but overall they're halfway decent. With solid state drives, when they were brand new, the only brands that I would trust are Samsung and Intel, because everyone else had issues where you would get corrupt and lost data, and even worse, it would kind of silently get lost and corrupt. So maybe this is just some of like history showing. So I still tend to buy Samsung and Intel drives. I don't think that's necessarily been a problem for a while, so maybe that's just me being overly cautious, but this Samsung drives are pretty popular. Let's just say 500 gigs. Some of you might want to choose a video card, so let's just choose one of the more popular video cards. NVIDIA tends to be pretty popular. And so usually it's like a third-party vendor that makes it so they buy the chips from NVIDIA and then they make their own card. So for example, MSI and Gigabyte here, we can see, so we'll just, we'll choose the second card here. So it's made by MSI, but it's, anytime you see this GeForce right here, this is sort of indicating that it's using NVIDIA's chips. We'll choose just any old case to save time. There are things that you have to, so there's different case form factors. Most people are going to use mid-tower or full tower. These computers in here, I think, are mid-tower. If anybody's seen a full tower, they're gigantic. I have a full tower, and sometimes I regret it when I have to, move it around to clean out the dust and stuff like that. But there's pros and cons. The pro is that a full-size tower is very easy to work with, and you never have room constraints. But, it's just large. And mid-tower, the reason actually I bought a full tower for my last PC build is because I had a mid-tower, and there were certain things that just physically wouldn't fit. I was having some issues with like video card height and length, and I just got really frustrated, and I'm like, I'm done with this. And so I got a full tower, and now I regret it a little bit because it's so large. But those are the main 2 things you're looking. Now there are some other form factors that you might want to look into that are kind of interesting. Like they'll have cubes, and sometimes they'll have cases where it's actually very easy to open and work on your computer, or other things like that. But we'll stay generic. We'll do a mid-tower, the very first one here. This one looks halfway decent. And then finally, a power supply. One of the nice things with this site is they give you an estimated wattage. And you could buy just above that, like you could probably find a 200, round up, a 300 watt power supply. What I've noticed is that there's sort of a floor. You don't tend to find things below 400. Now they are around and they are available. It's usually companies like Dell and HP that buy them up because they are very careful. They are like, they have engineers and they have like razor thin margins. What I usually do is, because for the difference for HP and Dell, adding $10 to a PC build, that's $10 out of their pocket. Multiply that by tens of thousands of computers, and then all of a sudden it's a lot of money. For most of us in here, having that extra security of knowing that your power supply isn't going to burn out very, very quickly. I usually just spend that extra little bit of money. And so even though it's only estimating 284, let's say probably in the 5 to 550 range. I don't want to get into this power efficiency stuff, but this one looks pretty decent, this Corsair. So and there's other little things here and there, but these are the main core components of a computer. Now, we did this in a few minutes. In reality, when you're going to build and buy a computer, most people tend to spend days or sometimes weeks. Like, they'll put a bunch of parts in their shopping cart, and then they'll stress over it. And because there are a lot of other considerations. There's like things like, is my memory going to fit with enough clearance? Is this a balanced system? So do I have one part of the system that's much faster or slower than the others, causing what's called a bottleneck? What other issues? Driver issues, like motherboards are pretty notorious for this. So if it's a brand new motherboard, it might have very good hardware specs, but the drivers might not be great. So drivers are essentially the software that makes hardware work. So there's a lot of other considerations. I don't want to oversimplify this process, but I kind of have to because, we're under time constraints. One of the things that's nice is that they have these completed builds. If you don't want to spend too much time thinking about it, that you can, and I think they do reviews and comments and stuff like that. So you might be better off looking at, if you don't have the time and expertise to go through and be very selective about each component, maybe you can use somebody else's as a starting point, especially one that might have been very highly rated. To be honest, I'm much less formal about it. I usually just go through and, I actually don't even use PC Part Picker. I usually just use Newegg, and it's just kind of a skill. After a few, you get halfway decent at building balanced systems. They might not be perfect, but we're also not engineers working for Dell where, every penny matters. Very quickly, one thing I just want to note, we're kind of limited on time. If you're ever curious, so I told you that when you're building tens of thousands or hundreds of thousands of computers, if you're like HP or Dell, those few pennies, if you can shave that cost off of a system, those few pennies are, they add up. And so there's a period about 10 or 15 years ago where it used to be so there's a type of capacitor called an electrolytic capacitor, and they're used on motherboards and power supplies and all kinds of other electronics. But in your PC, you're mostly going to see them on your motherboard and inside of your power supply. Now, Japan had a very good reputation for building very high-quality electrolytic capacitors, and it's not an easy process, and it's one of those things where you can build an electrolytic capacitor, and it seems like it works and it meets all the electrical characteristics, and then 6 months from now, it starts to break down, and it doesn't work right anymore. So China decided to get in the business of making electrolytic capacitors, and all these PC builders were like, oh, great. When I buy them from China, they're much cheaper. I already have other supply chains inside of China. I'm just going to start buying these. So Dell had a whole generation of computers. Now, this is going back a while. This is in like the Pentium 4 days, somewhere around there. And they built a whole generation of computers using these capacitors. Well, what happened? Over time, they started to break down. And these are, most things in your computer tend to be what are called solid state. They don't have moving parts. They don't have things like liquids and oils and stuff. Electrolytic capacitor is actually unique. They have this, I don't know how to describe it. It's almost like an oil inside of them. It's a little tiny can. Let me just show you a picture. I know I didn't spell it right, but anyway. Okay, and so for reference, this might be like the size of a quarter. Like this one might be height-wise, just to give you a reference size. And these would probably be about the size that you might see on a motherboard, maybe a little bit smaller. And so these are filled with like a liquid, Well, what happens over time is that this liquid will rupture the capacitor and leak. And once this stuff leaks all over the motherboard's damaged, and so after years and years of class action lawsuits and different litigation, Dell finally started to replace these motherboards, and it was just a giant headache for Dell. That's why I usually recommend, if you're in the position to spend a few dollars more when you're building your own system, to buy slightly higher quality components, I usually recommend doing that. And even to this day, one of the things I look for when I'm using power supplies is that they have Japanese capacitors, because I worked for an organization. We must have lost, it's hard to do an exact number, maybe 40 or 50 different PCs because of this. And it's one of those things to this day I still think about. So think about the quality of the components, not just the individual specifications. Now, like I mentioned already, in practice, you don't tend to actually do this. If you're working at like a large organization, if you're working in IT, what do? You go to your Dells and your HPs, because it's very, very, very time consuming to build many PCs. Like you can build a couple, so say for example you had a small office that you were running and you had to build 10 PCs, and those 10 PCs might last 5 years, then you might want to do that. But if you're like IRSC probably has thousands and thousands of PCs just all through campus, main campus, plus all the other campuses. It wouldn't surprise me if we have thousands of PCs. And they don't have time to go through and build every single one of these. So at some point you start having to rely on suppliers. Okay, any questions about that? I think we can put an end to that. Now, this doesn't really set the stage for the course, because we do a lot more questions like assignment number 3. But to me, this is always a fun thing, because usually, there's a few people in the class who have built a PC before, especially people who do gaming, but it's kind of a nice skill. Like I said, is that one of the things the book does is they talk about parts very generically. Like they'll talk about a CPU and a motherboard, but it's nice to know the actual specific brands and, in 2020, what are typical processor speeds and RAM speeds and so forth. Let's go through a quick exercise. We're going to go through a PowerPoint today on the different parts of a computer. Again, there are just certain it'll seem random things that we'll do throughout the class, but the reason I do them is just because I think they're very specific skills that you should have. They might not fit into a specific chapter of a book or a specific course, and so a lot of times I treat this class as the catch-all. Like, if I've seen seniors have issues installing software, or it's with some sort of specific thing, I'll be like, okay, this is a first semester class. Let me make sure that they get this skill early, so it's not going to be an issue later. So let's go ahead and install a piece of software. Now, for your assignment, it doesn't really matter too much what you install, as long as it's something reasonable. There's a bunch of open source software out there. I give you the suggestion, maybe Firefox, because a lot of you may not have Firefox already installed. On these school computers, it can get a little bit tricky, because I don't think they're set up to have admin rights. So you might have to be a little bit choosy, but more and more software I'm noticing these days is getting better about not requiring admin rights. Now there's a text editor called Atom. So let's go ahead and search for Atom text editor. And so again, follow along, because we're all going to do this. And so the website is atom.io, ATOM. And this is just a text editor. This is mostly geared toward programmers, but anybody can use it. If you're like a system administrator and you need to do some editing of some files that need a plain text editor. Okay, so let's go ahead and click download. Now, one of the things that you'll notice is this Atom Setup x64. Does anybody know what this x64 stands for? What's that? Yeah, exactly. And so give me another example. So here we're talking about x64. What's another example of maybe an older architecture? Exactly. So this x64 essentially means that it's for 64-bit computers. Now, pretty much these days, everything's going to be 64-bit. We haven't had that problem in a little bit of a while. So there's a period of computers where the process. I don't want to get into what 32-bit and 64-bit actually means. I guess I'll have to a little bit. But 32 bits, it just means that you can address 32 bits of memory. And so this 32 bits, that's just a number. Imagine 32 ones and zeros in a row. Now if you took those ones and zeros and you just flip them all to 1, so 32 ones, it turns out that number is around 4 billion. It's 2 to the power of 32. So why does all this matter? Well, billion, everyone in here knows like megabytes, gigabytes, terabytes, okay? So billion with a B, that's going to be gigabytes. Now 4 billion bytes is roughly 4 gigabytes of memory. And what was happening is that computers about, we'll say roughly 10 years ago, what was happening is that because they were 32-bit computers, you could install more than 32, or you could install more than 4 gigs of memory, but the computer wouldn't actually see it, if that makes sense. So it couldn't address past that, because if you flip all those 32 ones, it's a number around 4 billion, and that means you can't use anything larger than that. So what they started to do was switch over to 64-bit architecture, but this caused some problems because if I compile a program for 32 bits and 64 bits, they're not really compatible with each other. So what a lot of different software developers would do is offer 2 versions of the software, 64-bit and 32-bit. And so they compile them for both. And that way, if you're on a 64-bit computer, you could do that, and if you're on a 32-bit. Now, there's some compatibility modes and some other things that you can do, but in 2020, I would say if a piece of software gives you the ability to either do the 32-bit version or the 64-bit version, across the board, go with the 64-bit version. There's really not going to be any reason for most people in here to install a 32-bit version. There are special cases where that's needed, but they're just so rare. I don't want to talk about edge extreme cases in this class. I want to, everyone in here is kind of getting a gentle introduction. So this didn't even really ask us. This is, modern software, so it just assumed, hey, you probably want the 64-bit version. So let's go ahead and save it. Now, by default, it's going to want to save it in downloads. So let's go to our downloads. And then you can see it right here. You can sort by date. Let's go ahead and run that exe. So that's what's called a file extension. And the way a file extension works is that it's a hint to the operating system the type of file it is. So you can see here I've got zip files from a programming class I'm doing. I should have more examples. An Excel file, XLSX. And so those file extensions are hints to the operating system to tell it the type of file. Well, there's one that's kind of special, an exe. It's saying, okay, this isn't a data file. For example, like an Excel file or a zip file, that's data. An exe is what's called an executable file. It's essentially saying that it's a program. And this program is an installer. I hope this actually gives us some sort of options to do something along the way. Now, while that's going, so does everyone have that up and running, that installer? What I would like you to do, so don't do the assignment for Atom. Choose another piece of software. Again, Firefox works pretty decent. During that, you want to take a screenshot. Okay, well that... I'm going to uninstall this anyway, so no. Now, it's very often that you'll get some sort of options along the way. I'm noticing that's occurring less and less. But if you get some options along the way, you can just click next. It's what's called a wizard. It kind of takes you through the process. I have no clue where the name wizard comes from. It's kind of a strange name, but anyway, I think the Windows 95 days. Usually you can just accept the options. Usually it's options like where do you want to actually install this, do a desktop shortcut, those sorts of things. Now what I want you to do in your assignment is also take screenshots. Now if you can catch it during the install process, that really helps. That one you might have not got to quick enough. But there's a tool inside of Windows, it's called Snip. So if you go to Start and then start typing SNIP, this program will allow you to take screenshots. Now there's a bunch of different ways you can take screenshots, but what I usually recommend is that you go to Mode and then click this one here, Rectangular. And then all you do is just kind of highlight what you want to take a screenshot of, and then it opens it up in this snipping tool. From there you go to File Save. It defaults to, I think it defaults to your pictures, but here it's on my desktop, so that's fine. And then you might want to give it a good name, but by default it just calls it capture.png, which is fine for me. And then you click Save. So I know that probably seems like a couple of random skills to have, like building a PC and installing software, but to me it's one of those things that I've seen seniors not have that skill, so I want to make sure that certain skills don't fall through the cracks, like just installing software. And then when you've saved it, you can close. And at this point, I would imagine most people have the ability to submit an assignment through Blackboard, but all you do is click the assignment and then attach files. Now if you have multiple files you're attaching, what you do is you click Browse, you attach whatever, and then it'll give you another. So if you want to attach 3 files, you'd go through that process 3 times. You don't attach and then click Submit here 3 times. You would browse my computer, attach 3 times, and then it should show you the 3 files. Does that make sense to everyone? And again, I'm not tied to the specific software that you install. Firefox is a good choice. There's a piece of software that might be useful to you called Notepad++. I didn't do that in class today because I already had that one installed. There's a lot of freely available software out there that you can find. But again, the 2 defaults, if you can't think of anything else, you can either do Firefox or Notepad++. Now I'm guessing, I don't want to make too many assumptions, but most people in this program tend to play at least some video games, and usually you have to go through an install process in video games. So I'm guessing a lot of people have some experience, right, installing software like that. So, but there are some people who don't play video games and they, spend a lot of time on their phone, maybe just in app stores and websites. So I just want to make sure you had this skill. So let's move on from that. Now, time to get into the PowerPoint portion of the course. Now, I'm not huge on these PowerPoint slides. They're from the publisher, and I do what I can to kind of skip around to what information I think is important. But this is just a summary of what we've already talked about, the main parts of a computer. So the actual computer deals with input and output. Always remember that, input and output. So what that means is I give the computer input. Say, let's take the video game for an example. Is that I've got my keyboard and mouse, and I'm controlling some character in the game. That's input. I send my mouse clicks or my key presses to the computer, and the computer gets input. Imagine a game that had no input. It'd be kind of a boring game. You'd just be a movie at that point. You'd just be watching something. Now, output is the computer does a bunch of processing, and then it gives you back something. So we have input devices and output devices. Now, in this example, the easiest to think about is input is going to be your keyboard and mouse that gives the computer information. And then output would be your computer monitor. And that would be the actual rendering of the game. As you gave the game input to move your character around, you would actually see the results of that on the screen. But don't get too caught up in that, because there are a huge number of input and output devices. For example, your printer, that would be an example of an output device. It sends data out to some piece of hardware. Your headphones, that might be another example of an output device. Another input device would be, like, say, your microphone or a scanner. So a huge number of input and output devices. Don't get too caught up in this idea that computers are binary and use bits, because the full answer to that is very complicated, and one of the things that this book unfortunately does is it oversimplifies certain things. It's like, okay, now I know computers are binary, they use bits. What's next? What do I do with that? So maybe if we have time, we'll get into that. This is something that I want you to know, though, is this is kind of like your scientific notation. So the smallest unit of data that you're going to work with is the byte. So a byte is 8 bits. Don't really worry about that too much. Just think of a byte is like the smallest unit, 1 byte of data. What is 1 byte of data? So that could be an individual character on the keyboard. Like if I press the letter E, E is 1 byte of data. Does that make sense? So it's like the smallest unit of data that you can really do anything with. Now, because computers are so advanced these days, you wouldn't really describe things purely in bytes, because like I said, if you're dealing with a very large file that's in gigabytes, well, giga is billion. And so if I had like a 6 gigabyte file with some extra numbers, I wouldn't say 6,904, it would be a little bit ridiculous. So we might say it's like 6.2 gigabytes. So byte is just the base unit. Kilobytes is 1,000 bytes. It's a little bit more complicated than that, but just think about 1,000. Kilobytes is 1,000 bytes. Megabytes is 1,000 kilobytes, and so on. Okay. So in your head, think kilo, 1,000, mega, million, giga, billion, tera, trillion, and what's after trillion? I don't ever deal with numbers that large, so we won't worry about the last one. That's going to be a recurring theme. You're going to see that in both computer memory and storage. So keep that in mind. Now, there are different types of computers, but some of this stuff is so basic. I'm sort of assuming everyone knows that laptops exist and tablets exist and computers exist. So some of this stuff I'll go through. Now, input and output devices, this is kind of important to know. Like I said, a computer that's just sitting there by itself, imagine if you just had a computer not connected to anything, just no keyboard, no monitor, no network cable, none of that, just by itself. It'd be a useless computer. So what we need is input and output devices. Is that the computer gets input from the outside world, and then it does some sort of processing, and then it sends the output of that. And you'll usually see the acronym I/O for input, output, or I/O. And these are just some examples of input and output devices. I think most people have seen these before. We went over some. So your monitor would be an output device, speaker output device, headphones, same thing, printer. Okay, so now there are some that are combined input and output devices depending on what they're doing at the time. So for example, your computer's network card or its Wi-Fi, is that an input device or an output device? It's kind of both, yeah, because it can receive data and it can also send data. So it's just like whatever it's doing at that specific time. Maybe a more concrete, simple example is you've seen these all-in-one scanner, printer type things. And depending on what it's doing at the time, it's either, if it's scanning, it's going to be an input device. If it's printing, it's going to be an output device. Versus a dedicated device, there's not really a way to think about a keyboard as an output device, correct? I'm a little hesitant because I'm sure somebody's going to find some weird keyboard out on the internet, but the keyboards in front of us are going to be input devices. They just have one way about them. So we talked about this before, but the main components of the computer, and this was what I was mentioning, that's why I have you go on like Newegg and stuff like that and actually see some of these components, is that often the book is a little too generic. So they're saying, okay, these are the main components, is that we have the CPU. What does the CPU do? It does the actual calculations. It's very fast, and it can do very simple calculations like addition, subtraction. It can compare two numbers, to, like say, for example, if one number is greater or less than. So it does these very, very elementary calculations, but it does them very, very fast. So if I've got a computer that's, we'll just use a round number, 1 gigahertz. So that means it does, so giga is what? Thousands, millions, what did we just talk about? Giga is billion with a B. All right, remember kilo is 1,000, mega is million, and giga is billion. So it's doing 1 billion calculations per second. Now that might sound fast, but like I said, and that is fast, but all these calculations are very, very simple elementary calculations like additions, subtractions, and so forth. Now the computer, the CPU itself doesn't have, and let's take a step back. And what were the two main manufacturers of desktop CPUs that you're most likely going to see on the job? There's two big companies. Exactly, AMD and Intel. On phones, it's a little bit different. If we have time, I'll go into that. Some of you may have seen a name called ARM. Maybe some of you have seen a company called Qualcomm. The phones are a little bit different, and it's different enough that I want to maybe treat that differently. But just talking about desktop computers, so you get your CPU, and you've got your the two main companies that make CPUs for desktops is AMD and Intel. Now CPU itself doesn't actually have very much working area. It doesn't. Imagine if you had a desk and you're doing a bunch of calculations, you can almost think of you need some area to work with. Imagine trying to do a very large math problem on a tiny little post-it note. It'd be kind of tough. So what your computer's memory does is it's like having a very large desk that you can work, and it gives it the CPU areas to store data. Okay, and now you might only be able to write on that one little post-it, but then you can reach over and grab another sheet of paper and transfer it over, and maybe that's not a great analogy, but the idea is that the CPU doesn't have a lot of memory. It's very fast and good at doing calculations, but your computer's RAM, its memory, that tends to be very large. So CPU might only have a few bytes or tens of bytes of memory on board, what's called its registers. But RAM, you might have 1 gigabyte of RAM. And again, I just use round numbers. Typically today you'd see like 4, 8, or 16 or something like that. But let's just say 1 gigabyte of RAM, that would be 1 billion with a B bytes of RAM versus a CPU which only might have a few tens of bytes. Now, the specific way RAM works is that when you turn your computer off, all the RAM goes away. That would be kind of useless if you could only use a computer and then as soon as you turn it off, everything went away. You want to store things long term. So that's where we get into our hard drive, our storage device. And as I mentioned before, if I just took all these things and put them on a desk, I couldn't really make them work together, right? What do I have to have? What do I have to plug all these things into? What's that device called? Motherboard, exactly. And I kind of already went through this. You can think of it as the brains of the computer. It does all the essentially calculations. Memory doesn't do any calculations like your RAM. All it does is store data. And so all you can do for your RAM is say, store this data, or I want to retrieve this data. But the actual calculations on that data happen at the CPU level. Now CPUs, I'm not going to get into this too much because CPUs have gotten more complicated over the years. It used to be we just had single core processors and it was very, very simple to explain how CPUs work. If we have time, we'll get into it some more detail. But for now, just note that modern CPUs actually have multiple what are called cores. You can almost mentally think about it as having actual multiple CPUs working at the same time. We talked about this a little bit. This is what an actual hard drive looks like if you lift off the cover. The way it works is almost like a record player, is that you've got this platter, and then you've got this thing that has this tiny little microscopic head that reads those bits off of the magnetic platter. But we're moving more and more to solid state drives. Now, there's probably going to be a point in time where consumer computers don't use these. So we're doing good on time. Let's very quickly talk about the pros and cons of a hard disk drive and solid state drive. So to take a step back, if you think about in your head what a record player looks like, it's got moving parts. It's got this thing moving around. Now, a hard disk drive moves a lot faster. They tend to move at like anywhere from 5 to 10,000 RPM. That's the general range that they work within. So you're talking about this thing is moving really, really fast. It's not like a slow record player. So that means it has motors. What do motors make? Heat. They use a lot of power. But over the years, we've got really, really good at using hard drives, and they're relatively cheap. I can go on Newegg right now and probably find a, let's say 4 terabyte drive for under $100. That doesn't seem too crazy of an assumption. So they can store a lot of data, but they have a lot of cons. Now in practice, most people don't need that much storage. And we have this other type of device, which is actually relatively more recent, or they've gotten popularity is more recent, solid state drives. Solid state drives don't have moving parts. They use a lot less power. They don't generate heat, but they're much more expensive. So that same 4 terabyte drive, this is just off the top of my head. If you can even find one, it's probably at least $1,000. But in practice, people don't tend to actually need that much. Most people are okay with like 256 gigs or 512 gigs of a storage device. More and more people are storing their pictures on the cloud, and their phones have a lot of storage space. So you're seeing more and more people not necessarily need that much storage space. They're listening to many of their, a lot of their music and movies on the cloud, so it's not like you have to store them on your computer anymore. So I'm noticing that for many people, just a 256 gig solid state drive is good enough, and those you can get for about $100. So you might think, okay, well if that's the case, why don't these mechanical hard drives, if they generate so much heat and noise and all these other things, why don't they just go away? Is because if I'm running a large data center, if I'm Google and I'm running a data center the size of a football field, again, our concerns are always different than these large manufacturers. And to them, that extra cost of a solid state drive is a huge concern, because they need to, if they're a company that's storing the world's data, let's say for example Google has very clever ways of speeding up these mechanical hard drives, and they've gotten very good at working with them. And so even though they generate heat, noise, and all these other problems, is that to them it's still worth it that they might want to use that inside of a data center. Now, in practice, they use it mixed depending on what the goal is. Solid state drives also have the advantage that they're really, really, really fast. Like a number off the top of my head, let's say 3 to 10 times faster. They're much, much, much faster. And so if I'm Google, I might put data that I want to be fast on a solid state drive, and more long-term storage data like backups and things like that, I might put those on hard drives. So we're seeing kind of a mixed environment. That's why I'm saying I don't think that hard drives are ever going to go away. They've just gotten really good at making really cheap, large hard drives, and they're always going to be noisy and fast, or they're always going to be noisy and generate heat, just fundamentally how they are. But for consumers, I think solid state drives are going to be more and more about the future. Just out of curiosity, how many people on your own personal computer you have a solid state drive? Show hands. Okay. Few people. I was sort of expecting more. And you may not realize it, but on your phone, it's all solid state. So you're not going to have one of these drives on your phone. And by the way, the reason that they do that on the phone is because when you have a lot of moving mechanical parts, if you drop it, and it's what's called a head crash, you actually have a magnetic platter and something reading from that, and if you drop it, it can actually crash into it, and then magnetic little bits go flying everywhere. So, and these are some other types of memory, of storage. We're not going to get into it too much. We're seeing less and less what's called optical storage. These were very popular at one time because, so let's take a DVD for example. Yes?
Yeah. For me, the trend that about laptops that I'm getting really upset is that more and more companies are removing the DVD drives.
Oh, yeah.
And I really don't like that because my favorite game is actually Roller Coaster Tycoon 3, and that game is.
Oh, yeah. Is it DVD only?
DVD only.
Yeah.
DVD. So I'm like, I need to find a newer laptop to run that game, and I see more and more companies removing that. I'm like, I want to play this game then.
Yeah, and I don't know if you were able to hear him, but yeah, and I'm checking on mine. I had never really even thought about it, but yeah, mine doesn't have one either. Yeah, the trend is to save space. A lot of the laptop makers are getting rid of optical storage drives to save money, and that's great. But most people have things that are still stored on DVDs. Like maybe they even have. So in your case, it was a game, but it might be family photos. It might be if you're working with industrial software, and a lot of times. Maybe if it's family photos, you could copy those over, but for that game, I'd imagine there's probably something about that game that you just can't copy the DVD. There's probably some sort of, maybe some copy protection or something where they make you have the disc actually in there. Now the reason that optical storage was so popular is because it's cheap and its price versus storage is huge. So let's say, for example, we're just going to use rough numbers. Let's say a DVD is around 5 gigabytes of storage, and 5 gigabytes for less than $1. That's pretty good, especially if you have some data that you want to give to somebody. They're relatively, I mean, you could scratch them and stuff, but they're relatively rugged, as in like it's kind of hard to break them. I mean, you can, if you really try, you can scratch them and snap them and stuff. But if you put a DVD inside of a case, they generally last a pretty long time. The one thing that they were not great is that they were relatively slow. And sort of what happened naturally over time is that a lot of things moved to the cloud. So, and you probably noticed this a lot with like games and stuff like that. More and more games are moving to the cloud. Flash drives have become very popular because even though if you take care with the DVD or CD, you can still scratch it. It's very, very difficult to break a flash drive. Some of them you can even drop into water, and roll over with a truck and stuff like that, and they can still last, like some of the really rugged flash drives. This sort of naturally happens over the time in the computing industry. At one point, does anybody remember floppy disks? That sort of happened with that, is that over time what they do is they claim it's like to look to the future, but you have to think, if you're in their shoes, they're always looking at ways to cut costs. And if only, say, 10% of their customers are requesting DVD drives, they just look to cut those costs and they'll get rid of it. Because everyone always wants to advertise that they're the thinnest, lightest laptop. And now, one thing that you can do, that it doesn't always work, but a lot of times what they'll do with these devices that they don't include in the computer anymore, sometimes you can buy it as an external, something that you can hook up USB. Does that work for your game? Or did you try it with that game? Okay. And those run about $20 to $30, is that they'll actually have external USB. And that's actually what I have. So a lot of my devices these days don't have a dedicated DVD thing anymore, and I don't even know where it is. It's been so long since I've used it, but just have an external USB DVD drive. Now, when I've got a separate device, say for example your phone, or going back in MP3 players, or let's say a printer, many times I want to hook that up to my computer. Now, more and more things are going wireless these days, but wireless in general tends to be slower than wired. Now, I'm sure you could find a specific wireless protocol and you could, but in general, this holds for a lot of reasons. So, when you need to transfer data back and forth between a device, especially if it needs to be at high speed, you generally plug it in with some sort of cable. Now, in the early days of computing, we had what were called serial cables and parallel cables, and they were extremely, extremely slow, and devices, things weren't often compatible. And so sometime in the mid or late 90s, a bunch of companies got together. I think Intel was the largest of them, that said, and Microsoft was heavily involved too, we need to create one universal cable that works for everything. And it needs to, all the software that works with it, it's universal. And then within that cable, what will happen is the software will say, okay, this is an MP3 device, this is a printer. So all the negotiations will happen over the cable, but it's going to be one single cable, and it's going to be universal, and we're going to call it the Universal Serial Bus. It's going to be called USB. Well, what happens with anything that's universal is that they say, okay, well, we're going to come out with a second version that's a little bit faster, can carry more power and do this and that. And then this next version, the connector is going to be smaller. And then over time, it's evolved. And so it's a little bit more complicated. It's not like we have one cable anymore. So with USB, we have Type A, Type B, and Type C connectors. And then within that, we have various standards. But for the most part, they've tried to make it that if the cable fits, the data is going to transfer. They've been pretty decent about that. But there are various standards in different cable types even within USB. So just something to keep in mind. But that's generally when you're working with wiring your computer to a device, typically to transfer data, sometimes just to charge it, but typically for data, that's usually what you're going to be using as some sort of USB cable. This is not that important. This is, I guess, important, but it's probably outside of the class. In practice in IT, you tend to spend a lot of, unless, I don't know, I was a programmer, so I'd spend a lot of time at my desk. But if you're working in other areas of IT, especially networking, you spend a lot of time on your feet all day. So, okay. Let's just get it. So that's pretty much all the stuff I had already said by visiting Newegg. That's just kind of the PowerPoint version of it. And I'll post these soon. It looks like that what happened with the publisher is that they sent me blank PowerPoint chapters, so I'm going back to last semester's. But I'll make sure to take care of that. I'll get those posted. So this next chapter, this is going to be, and I'm just going to give you a preview of this, and maybe I'll give you a few minutes to do your assignment. This next chapter is on the internet. And I just want to kind of preview this, and then we'll spend all of next class on this. So if we go back to the history of computers, when they first created computers, it was like this amazing thing. They would have all these people sitting in a room doing a bunch of calculations. That was their job. All day they would just do all these calculations, and they said, can we come up with some sort of device that can do this? And if we can come up with a machine to do it, that means that the machine never gets tired, the machine never makes mistakes. You know, it's a machine. Whatever you program to do, it's going to do it over and over and over again. And so they eventually created that. And the first computer is called the ENIAC. And they were super happy, and over time they started to make them smaller and smaller and smaller and faster and more powerful. And as that happened, you had all these different computers doing important things. Now, one of the things you may want to do is have a computer, quote unquote, talk to another computer. I've got computer A, so let's give a real world example. If I'm MIT on the East Coast and Stanford University on the West Coast, and we're both working on physics experiments, and I've got some data and results I want to give back and forth, well, I could print up all that data, load it up on a plane, send it over to the West Coast, and they could type it into their computer. But it'd be nice if there was a way to do that electronically. And during somewhere around the 60s, early 70s, is when they decided, okay, let's come up with a way to do that. It's impractical for us to send data on planes and trucks. What if we can directly communicate to computers together? And so they came up with various ways to do that. We'll talk about some of those. But then the next question is, with two computers talking to each other, that's relatively easy. I can just say, okay, I want to talk now. One computer sends, the other one says, okay, now it's my turn to talk. What about if you add a third computer? or a fourth computer, a fifth computer, or infinite number of computers. And that's where it gets kind of tough, because you have to come up with a system where everybody can communicate and you negotiate what's called traffic. And that's where this protocol TCP/IP, which some of you may have heard of before, that's like the protocol which made the modern internet possible. Now, what is the internet? So let's go back to our first example. If I have all these computers in the classroom and I want to make them talk to each other, be able to send and receive data to each other, well, what I could do is I could hook them up with a network cable, all, let's say 20 computers, and I could put them into a box, and they all could talk to each other using TCP/IP. Well, that's great. What if I want to talk to the classroom next door? What I could do is take all these computers, put it into that one box, and send one cable next door. Well, what if I want all the classrooms in the building to be able to talk? Well, I would take all the classrooms. I don't necessarily need to hook every computer up. I'd hook each classroom up into one device and then run that one cable down to the building. What if I wanted to connect all the buildings on campus? I would do the same thing. What if I wanted to connect the campuses together? What if I wanted to connect IRSC to Palm Beach State University? What if I wanted to start letting people at home start connect to this network? And so that's what the internet is. The definition of the internet, it's a network of networks, is that we take these very small networks, we plug them, so we take a bunch of computers, plug them into a device called a switch or a router, depending on what you're trying to do. We hook all these different switches and routers up together, and then we keep on doing that in more and more larger scale until we have the internet. And so what happens is, if I want to communicate out to California, what will happen is I'll send what's called a packet to the router in this building, and then that router might go to connect, let's say Comcast locally, let's just say somewhere out somewhere here in Fort Pierce, and then from there it might connect down to Miami over these very, very large tunnels, what we call backbones. And then from there, that backbone may connect out to San Francisco. And then from there, San Francisco might say, okay, how do I get to the local destination? You could almost think of it, that's the same way they send mail. Is that if I send a piece of mail that needs to go to California, first I send it to the local office, and then they take it to some processing center, maybe in West Palm, and then maybe that goes to Jacksonville, and then maybe that goes on a long haul truck all the way across the country. It's kind of the same thing. And so that's the internet, and that's going to be the next chapter. We're going to get into that in some more detail, but that just sort of sets the tone. So we have 10 minutes of class. Usually this is like, when I teach, this is the full-length class, so we'll have more time to work on the assignment, but I want to at least give you a chance to get started on the assignments, and if anybody has any questions, I can help you individually. So let's do that. Let's reserve these last 10 minutes. If nobody has any questions, just to get started on the assignment. I know you're not going to be able to finish, but at least get started. Okay, so any questions before I stop the stream?